Welcome to solverfy.
So I want to sketch this function x cubed minus 12x from -4 to +4. And I'm just using a y-scale of -20 to 20. So I've got a point at the origin at -2, so let's say 5, 10, 15. At -2, I'm at 16, and at +2, I'm at -16. And I'm going to be a little more than here, and 3.464 here. Okay, so my graph is going to look like this on that interval. And let's see what we need. So we need intercepts first. To get my y-intercept, I'm just going to set x equal to 0, so I can see that my y-intercept is 0, 0. My x-intercept, I'm going to let y equal 0. I'm going to factor out an x. So I have x squared minus 12. So my x-intercepts are going to be at 0 and at plus or minus the square root of 12, which is 2 radical 3. So my x-intercepts are going to be -2 rad 3, 0, and +2 rad 3. My y-intercept is just going to be 0. And there you have those. I'm going to indicate extrema. So I'm going to take the derivative, which is 3x squared minus 12. Set that equal to 0. Factor out that 3. So I have critical values or critical numbers at plus or minus 2. So I'm going to put them on a number line. If I put in a value less than -2, I'm going to get out a value that is positive. -1 will give me a value that's negative, and 1 will give me a negative, and 3 will give me a positive. So that means my graph is going to be going up, then it's going to come down, and then it's going to go up. So I know that I'm going to have a relative maximum at -2 and a relative minimum at +2. And I just put those values back into my original function g, and that's going to give me 16 and -16 for the y coordinates. Okay, what else do I need? Points of inflection. So I want my second derivative now, and that is going to be just 6x. So set that equal to 0, and I get 0. If I plug in something negative less than 1, I'm going to get a negative, and then I'm going to get a positive. So I'm going to be concave down and then concave up because I have a change in concavity. I have a point of inflection at 0, 0. Behavior near So the function is defined everywhere. This is continuous, so function defined everywhere. And I'm just going to put here because it's a polynomial. The behavior at infinity as x goes to positive infinity, g of x is going to go to positive infinity. As x goes to negative infinity, g of x is going to go to negative infinity. We know that because our ends are going up and down. At these singular points, I'm not sure, it's hard to read this, but, as x goes to 0, g of x goes to 0. So for those singular points, because it's defined, whatever x is going to go to is going to be the value of g at that point.